Hello students. So in this video we'll discuss about ambiguous grammar. In the last video we have discussed how to construct the LLR parser, and I told you the comparison of grammars. So where the ambiguous grammar is not going to be deal with any parser. So immediately may get it out. What does it mean by ambiguity? See, a grammar is said to be ambiguous grammar if it generates more than one parse tree for the same string. Assume that we have a grammar like this. And for id plus id star id, I could able to generate the two different parse trees. See, these two are different. Or you have taken same leftmost derivation. In each and every step, I replace the leftmost non-terminal only. So if I give the two leftmost derivations for the same string, right? See, e, leftmost, right? I gave the two different leftmost derivations for the same string, or simply two different parse trees. Then I can say that the grammar is ambiguous grammar, right? Then what are the problem with that? First of all, can't we construct the table? Yes, we can construct the any parsing table, ll1, backtracking, recursive descent, clr, lalr, everything we can construct, but you are going to get the conflicts. That's a problem. So then how we have to remove it? So there is a possibility of removing the conflicts by utilizing the associate property, precedency property, or we can eliminate it, or we can convert the ambiguous grammar into unambiguous grammar, or sometimes we can perform the unnecessary reductions, okay, eliminating the unnecessary reductions. So we can handle this ambiguous grammar. So first, how to modify it? See, we can eliminate the ambiguity by performing the left factoring of the grammar, sometimes eliminating the left recursion, or using precedency and associativity of the operators. So these are two different concepts. Let me first explain the precedency and associativity. Here we have, see, this E tends to E plus E. This left hand side non-term is occurred as a leftmost symbol and occurred as a rightmost symbol. So in any production, if the left hand side non-term is occurred as leftmost and rightmost, then we can call such grammars are ambiguous grammars. Definitely you are going to get more than one parse tree for some string, right? Then how can you change it? See, here we are having plus, star, parenthesis and id. So if you want to give more precedency to the star, then you have to take it to the next level. So instead of using the same symbol here, what I'm doing here, E tends to E plus introduce a new non-terminal T, right? Then directly when you can go to the T. So what is the T is having? T tends to T star. Again we are going to have the same symbol, right? You can write a new non-terminal. For this F, you can take the parenthesis E or ID because we don't have two redundancy of non-terminals. See, going down, the precedency of the operator will be increased. Sir, I want to make the plus is left associative, then you write it. For example, if you want to give higher precedency to the plus, then followed by star, and plus is right associative and star is left associative. If you want to give like that, then you can do this. What is the higher precedency plus? So you should keep it in the end. Then you can write like this. So E tends to E star T or T. Then T tends to, see, plus is which associative? Right associative. Then you outright like this, F plus T or F. Then F tends to, in brackets, E or ID. See guys, if you want to give the higher precedency to the star, then you outright the star in the next level. Plus, if you want to give higher precedency to the plus, then you have to mention it. But see, here the plus is left associative production, left associative. But here star is left associative as left is occurred, but plus is right associative as T is occurred as a right to most symbol. There is a difference, right? So in that way you can eliminate the ambiguity from the grammar. There's a third way. And first way is left factoring. What does it mean by, first of all, left factoring? See, if any symbol is occurred more than one time, right? sorry, if any term is occurred more than one production, is occurred in more than one production from the left side, like alpha beta, alpha beta, alpha beta, common symbols in more than one production, then we can say that left factored, like C equivalent to, in mathematics, AB, AC, AD. What you can write? You can write C equivalent to A one time, B plus C plus D. Then you can write C equivalent to AX and X equivalent to B plus C plus D. That's what you have done, right? In mathematics. Same way. See, this is A common. Then what we can do, if A alpha is common, A alpha is common, A alpha, this common one you take only one time. For the uncommon thing, you introduce a new non-terminal A dash, right? So this is A dash, A dash, A dash. So A alpha, A dash. What is A dash? The uncommon parts. Alpha 1, alpha 2, alpha 3. That you can take it, right? So here they're assuming that alpha 1 and alpha 2 are same symbols, guys. If there are different symbols, you can take A alpha as a common term. Okay. Like you can write in this way. A alpha A dash. Then you can write A dash tends to 1 or 2 or 3. Of course, they didn't mention clearly what is it alpha 1 or alpha and 1 are separate. They didn't mention, right? So that's your wish. What do you want to take? So left factoring. So we have to remove the redundant part by taking only once. For the uncommon thing, you can introduce new non-terminal. Same way, you can take this example here A, A, B, C. What is a common part? A. So for the uncommon part, you can take a new non-terminal, right? But you have to ensure that if it is common in one production or more than one, that, see guys, you can take first A, no problem, not an issue. Let me write it. A tends to A X, A dash or X, whatever it is. X tends to, you can write AB or BC or AC. Now again A is common here, see. Here it is not common, you take it as it is, but A is common here. Then what we can write here once again, A tends to AX and X tends to AY or BC, because BC no common thing. Don't take B common here, must be from left side only. Y means B here, C here. Then you can write Y tends to either B or C. That's what we got here. In place of X we got the A dash. In place of Y, I got the D. That's it. See, you can do whatever way. First, you can take the common of A directly, or you can take the common of A. That's your wish. But at the end, you should get the same. But here, what they have taken first, A common, right? Okay, we have done the same thing, right? Let me take A common, no problem. Sorry, we have done the same. Let me take A common, no issues. See, A tends to, here A is common in two productions, right? Then you can write it. A and BC is ABC is not, right? Then you can write ABC, AX. So what is X here? As you have taken A common, B or C, then you can write B or C. Now again A is common here. Then again perform the left factoring. So A tends to AY, where Y tends to AX or BC, and where X tends to B or C. See, we got it. Forget about the names of these newly introduced non-terminals, but we got the same terms or not. That's how you're going to do, right? So another one, left recursion. So what does it mean by left recursive grammar? If the non-terminal is occurred as a first symbol in the production, leftmost symbol, then we can say that it is a left recursion. The problem with the left recursion is it'll keep on substituting, the production will enter into the infinite looping. So that's a problem. Then how to remove it? If it is like this, then simply you apply the method like A tends to beta A dash. So here beta, right? Beta A dash, where A dash is a new non-terminal, and A dash tends to alpha A dash or epsilon. Just remember this formula. Okay. So how we got it? We have a big proof for this, but we don't require now. So if it is a left recursive, Then identify what is A, what is alpha, what is beta, then simply substitute it. Let me explain with an example. Here A, so this is A and this is alpha 1 and again A, alpha 2 and beta, right? So what we can write, A dash tends to alpha 1, BD A dash, alpha 2, A dash or epsilon. That's what we have done, right? So beta A dash tends to alpha A1 or epsilon. Here we are having two alphas, then you have taken two times. Now see here, again B. So this is A, alpha, beta. Then you can write B tends to B dash and B dash tends to alpha, B dash or epsilon, E, like that. If it is only one alpha, write one time. If it is more than one, write two times. Same way here. So this is A and this is alpha 1, same A, alpha 2, beta. Then how can I write it? E tends to beta A dash, means A dash or E dash, whatever it is, A. And A tends to, new non-term tends to alpha 1 plus E dash and star E dash, I mean say that A or epsilon. You can take it, whatever it is. Forget about the new name, guys. Or how can I write it? E tends to beta A dash, E dash, E dash tends to alpha E dash plus E dash or star E dash or epsilon. Where I have taken E dash here, they have taken A here. No problem. There is no logic behind that. Okay, you can take whatever the new non-terminal you want. So then this how we are going to deal with left recursion. For example, still you want to deal with the ambiguity in the table. So assume that we have, this is a grammar, we have constructed SLR1 parser. Take the seventh state, guys, here. Now see, we have a complete item. So that's why we have performed the reduce action here. R1, and we have a shift plus and star. So now how to handle this conflict in the table directly, not in the grammar. So now this S4 we have performed because of this plus, and this R1 we have performed because of this plus, right? Same way S5 we have performed because of this star, and R1 we have performed because of this plus. So if you want to give more priority to the star, then keep the S and remove the R. So just we are eliminating the plus because of star is given higher precedency. Same way plus and plus. So we are having like this, plus E dot plus E. I'm just combining these two productions. So we have a plus before dot, we have a plus after dot. So if you want to give, so before dot we have a plus and after dot we have a plus. So if you want to give the higher precedence to the left plus, right, means before dot plus, then what we can do, keep the reduce and remove the shift, because I want to do the higher precedency to the plus, left associativity, like that. So here see guys, let me just explain this once again. Now see how I got these two items. See, in I7 reduce we have performed for this, shift we have performed for this. This is S4, this is S5. Then reduce, this is R1. So if you want to give higher presence to the star, then remove the reduce, keep S5. And for this plus, if you want to give the higher presence to the left plus, because that is before dot, then remove the yes after dot, keep the R1. So same way we have done here. See, we kept R1 and S5. Same way here, this is reduce R2 and this is S4, S5. So R2 and S4 give the higher presence to the reduce. That's why I keep R2. And R2 and R2, I want to give the higher presence to the left star. So that's the reason I just kept. So you have to decide whether you have to give the higher presence to the symbol before the dot or after dot or operator. That's your wish, what do you want to do. So this is how you are going to deal with the ambiguity. So in the next one we will discuss about parser generators.